There are a number of essential concepts in systems thinking. Many of these are familiar terms in other fields, but have a particular meaning when talking about complex systems. For example, feedback, variables, and causality. In this ILO, you will be introduced to some of the most commonly used terms and concepts within the field of systems thinking. This will allow you to better understand systems as a whole. We've organized your prescribed reading on this topic into a 6-step process for systems analysis. We believe that this will help you with not only understanding the key concepts, but also how they fit together in developing systems thinking. The 6 steps are: firstly, tell the story, name the variables, determine the system boundaries, sketch the trends, make the system visible, and finally, look for leverage for sustainability. It probably doesn't mean much right now, but we will work through each of these steps to make them clearer. Systems thinking begins with a story, which is an account of some particular event or events. You should tell the story you want to analyze with one or more people. Use your own words and encourage listeners to ask questions to clarify their own understanding. Therefore, everyone should be clear about what the story is about and the scope or boundary of the story. For this section, the event we will look at for illustration purposes is the decline in the global population of whales. Following the event, you then need to name the variables, which are a set of nouns or noun phrases that go up or down over time. In the whale example, these could include things like the whale population, the birth rate of whales, the death rate of whales, the amount of funding that whale research attracts. Notice that each of these variables goes up or down over time. There are a number of boundaries in the system under analysis, that's the whale system. You could consider the boundaries to include the political, geographical, and even the whale species boundaries. All these systems serve various purposes. However, given the decline in whale species, there appears to be an imbalance in system boundaries and the effect they have on each other. So you always need to ask, is the boundary that you set around the system appropriate for our analysis? One of the basic systems thinking tools is a behavior over time graph. This is a visual tool which helps us see trends or how variables change over time. Sometimes sketching more than one variable on the same behavior over time graph can help us see a relationship between the variables. From this graph, you can see that the y-axis represents the element that's changing, while the x-axis always represents time. The blue line, or the actual behavior over time graph, tells a story of how a particular element changes over time. To put this into context, if we were to look at the trends in the whale population, you can see from the graph that in the absence of commercial whaling, the natural birth and death rates of whales kept the population fairly steady. However, as a result of commercial whaling, the population began to decline quite significantly. This has been averted somewhat by the intervention of the International Whaling Commission, which has resulted in the population displaying an upward trend now. There are also many graphic tools that can be used to better understand a story. In this step, we will look at two in order to help you see the dynamics of a system by looking at the relationships among its key variables. And these two graphic tools we'll look at are called stock of flow diagrams and also feedback loops. Let's start with stocks and flows. A stock is the foundation of any system. Stocks are the elements of the system that you can see, feel, count, or measure at any given time. and they change over time. They either go up or down. So if you look at this bathtub example, the amount that it's filled depends, or the stock in the bathtub depends on how much water is entering the bathtub and how much is leaving. So basically, the faucet and the drain are the flows in this case. So when you add water, the level rises. When you drain water, the level drops. So the stock represents the amount of water in the bathtub, and the inflow and outflow are represented by either adding or draining water. Here are some other examples of stocks and flows. So in your bank account, for example, whenever you deposit money, the stock of money increases. Similarly, as we add more carbon dioxide into the atmosphere, the stock of CO2 rises. With your self-esteem, if you're looking to build it or to grow the stock of your self-esteem, you need to encourage positive activities that build on it. However, as we saw early on, stocks rarely only increase. There tends to be a mechanism by which they decrease over time. So a feedback loop is formed when changes in stock affect the flows into or out of that same stock. So for example, the total amount of money in an account affects how much money comes into the account as interest. So the more money you have in the bank account, the greater the interest, or rather the interest rate is steady. However, the interest rate has the result of compounding the amount of money you have in the bank. It's now important to distinguish between what's called a balancing feedback loop and a reinforcing feedback loop. Look at this example of a coffee drinker and the body's ability to restore balance. So drinking coffee naturally increases your energy levels, and that energy is used up over the day. If there's an imbalance through either too much or too little energy to do your work, as a coffee drinker, you can adjust the amount of coffee you drink in order to keep those energy levels at the required state. Of course, I'm in no way encouraging you to drink too much caffeine. However, this example just illustrates how the body's energy levels balance themselves out and how they signal to the individual to either drink more or stop drinking the caffeine needed. Runaway loops, on the other hand, they have a compounding effect. So while the balancing loop allows for inflows and outflows to regulate the stock, in this case, the effect of, say, interest on the left or increasing birth rates in the right diagram, in each of these cases, the increased flows result in increased stocks, which multiply and cause a runaway effect. So with a bank account, the interest has the effect of exponentially increasing the amount of money that's held in the bank. Similarly with population, you've probably heard that population increases at an exponential rate, and that's because of the compounding effect. As there are more people in the world, they have more children, and hence the overall population rate increases. So as the slide illustrates, it reproduces itself to grow as a constant fraction of itself. Now returning to the whaling example and bringing it all together, the diagram as it is highlights the natural order of the whaling ecosystem. Whale births and deaths form natural breaks to maintaining the population. Think for a moment if there were no checks on the death rates of whales, such as what happened in Australia with rabbits. The reinforcing loop enabled by the environment led to an uncontrollable rise in the population of rabbits. However, in this case with whales, the opposite is true. With commercial whaling, the death rate rose at a higher rate than the birth rate, thus decreasing the stock or the whale population over time. At this point, you might be asking, so what? How does all this analysis of variables and causal loops help everyday people deal with sustainability issues? Well, that's a good question. And to understand the answer, we need to weave into our systems analysis a critical missing component, that of human impact on the natural world. For a variety of reasons, often good ones, humans disrupt the patterns in nature. In systems thinking language, we could say that our daily actions impact one or more variables in a system. Because many people are unaware that when they tinker with one part of a system, it affects everything connected to it. And as a result, we end up with unintended consequences such as overpopulation and climate change. Systems thinking helps us to see how our actions may or may not be contributing to the sustainability of our environment. Once we know how the natural patterns of a living system work separate from human impact, we can then more easily see where and how people's choices have interrupted and redirected cycles. And we can then consider ways to shift to more sustainable options based on our new choices. And that is what is called leverage, the ability to intervene at different points in the system in order to make change. So in the whaling example, when the International Whaling Commission intervened through working with the various political, economic, geographical, and ecological systems, they were able to effect change at the right points using the right leverage in the system.